Hello, everyone, and welcome to TE Connectivity's TE Powertrain Revolution webinar. Today, we will be talking about the significant changes underway in the automotive industry powertrain segment and how TE fits into this changing world. Since the inception of the automobile in the early 1900s, we have seen regular improvements in power, efficiency, safety, and convenience items, all of which have been staples on the plate of customer wants, and more recently, expectations. Options like power steering, power windows, and air conditioning are no longer options. They are expectations. What hasn't changed much until recently, however, is the ability to choose powertrains. Take a look at some of the recently published statistics on the subject. It is expected that by 2030, up to 50% of new cars sold will contain electrified powertrains. We are also seeing an increase in customer acceptance of vehicles with electrified powertrains. Perhaps not surprising, however, we find that relatively few people actually seek out this emerging technology when purchasing a vehicle, and the more inquisitive among us will ask why. Well, the answer to this question may have as much to do with perception as reality. Alternative powertrains are often polarizing due to political, environmental, and economic factors, each of which has elements of perception and reality, which are equally valid in the mind of the consumer. I, for one, tend to believe that my political motivations are based entirely on fact. Now, kidding aside, what we've come to understand over the last 10+ years of engineering in the high voltage space is that the development of electrified powertrains is not solely driven by altruistic reasons like saving the environment. And yet these are often the first things that come to mind when we ask a potential customer why they do or do not purchase an electrified powertrain vehicle. We're finding that there are tangible benefits to electrifying even portions of the powertrain for perhaps less noble yet desirable results, such as instant torque to the wheels or powering accessories that otherwise put parasitic losses on the internal combustion engine. The point here is that as system electrification becomes more prevalent, not as a result of political or environmental motivation, but as a result of tangible performance and convenience enhancement, customers will come to expect the new norm, and the powertrain revolution will continue to expand. Now, no review of electrified powertrain possibilities would be complete without at least a cursory accounting of all the factors affecting the industry for better or worse. Regulations, energy costs, and consumer sentiment all push this industry in different directions. As we dive a little deeper, we get to the core of the challenges to powertrain electrification. Chief among these factors are consumer sentiment and economics. These two elements arguably will determine the success or failure of the alternative powertrain initiative. Let's put it another way. Offer the customer a quality product, there's your consumer sentiment, at a price point that's both affordable and generates a profit, there's your economics, and you have the model for a successful business opportunity. It is in this spirit that TE brings its long-standing experience in automotive connectivity and high voltage power systems together for truly integrated products in this changing automotive space. Let's take a look at some key functions within the electrified powertrain and how TE brings value to these areas. The electrified powertrain world is one in which systems are constantly reacting to one another. Our ability to detect changes in state, whether thermal, electrical, or mechanical, is at the heart of our ability to run a vehicle entirely, or even just in part, with electrons. With this in mind, we'll start with sensors, and no automotive-related discussion is complete without mentioning racing. The world of auto racing generates valuable opportunities to implement and test the latest technologies. Following the powertrain revolution theme, we have the Formula E class of racing, which takes an IndyCar-type platform, you know, the open-wheeled race cars, but instead of a typical internal combustion engine, the power plant is electric. TE recently partnered with Andretti Technologies in the Formula E program, incorporating the EB100 series pressure transducer in their Formula E car's gearbox to monitor oil pressure. Additional sensors in this application monitor position or displacement, temperature, and acceleration. In a typical combustion engine, TE sensors are used in applications such as turbocharged boost, pneumatic cylinder cam, and crankshaft speed sensing. As we transition to alternative power plants, TE can provide e-motor resolvers and other application-specific sensors to monitor battery and coolant temperatures, for example. Other critical factors such as speed, position, and vibration can all be measured with our sensors through both analog and digital means. In many cases, we have incorporated multiple parameter measurement in one sensor, for example, combining elements of pressure, temperature, and humidity. Electrified powertrains come with some unique requirements not found in their internal combustion-based counterparts. One of these unique elements is the need to make and break the power from the battery. As power and voltage demands have increased, TE has adapted our family of contactors to keep pace with customer requirements. Looking at a typical electrified powertrain, one finds several applications for high voltage and high power make-break capability, including the main power supply to the battery, where a contactor is used to control the main positive and negative circuit connection to the rest of the vehicle. Other connections include the charger, where a contactor is used to establish the connection between the battery charger and the battery. Further, contactors are used in auxiliary connections, where they control other electrical loads, like the electric heater for the passenger compartment in a full EV, where no waste heat from a combustion engine is available for this purpose. High voltage contactors may also be used in stationary systems like DC charging stations, stationary battery storage systems, and uninterrupted power supply systems. To spotlight a specific product, TE's EVC 250-800 contactor, launched in 2017, is designed with a rated load voltage of 800 volts. The internal design ensures creepage and clearance distances according to IEC 60664 up to 1,000 volts for industrial applications such as commercial vehicles, trucks, and buses. Of course, connectivity is a major aspect of successfully propelling a vehicle down the road with an electrified powertrain. In the case of full electric vehicles, we have to get power from the charging station to the vehicle. But even if charging is not a requirement on a typical hybrid powertrain vehicle, we still have to safely pass power through the vehicle. Some of the major categories of connectivity covered in today's electrified powertrains includes the charger inlet to the onboard charger unit, DC power from the battery to the inverter and accessories, and AC power from the inverter to the motors. Covering the vehicle side of the charging path are TE's AMP+ HVA 630 terminal and connector systems, which provide advanced high voltage protection to hybrid and electric vehicle onboard charging systems. The HVA 630 connectors and headers are available in 2- and 5-pin options with integrated internal high voltage interlock circuits, or HVIL, to keep the package size as small as possible. The 5-pin version of these connectors allow 3-phase charging currents up to 32 amps, while the contact systems are designed with shielded multi-core wire for conductor cross-sections from 2.5 up to 6 millimeters squared. This connector product family is touch-safe, provides CPA, and is designed to meet AK 4.3.3 and LV 215-1 specifications. When it comes to the high power needs of the battery to inverter and inverter to motor, TE's AMP+ HVP 800 high voltage connector system will carry up to 250 amps continuously on 50 millimeter square wire. These lever-assisted, touch-proof 2- and 3-position connectors and headers are designed with 90-degree and 180-degree plugs and feature integrated internal HVIL function and EMI shielding. TE covers the accessory load requirements with our line of AMP+ HVA 280 accessory connectors, which are used by several OEMs to reliably power systems in the 15 to 40 amp range. This terminal and connector system includes fingerproof, touch-safe 2- or 3-position, low to medium current plugs and headers with integrated internal HVIL and multiple key options. In addition, the HVA 280 product family includes a discrete header design unique to the industry that improves packaging and manufacturing efficiency by allowing the connector to be assembled from inside the device. Moving on from accessory connections, we will review one of the key components supporting the e-mobility trend, which is charging cables. These cables are seen as a major element impacting end customer satisfaction, considering that the complete functionality of the car, recharging or refueling, if you will, depends on this function. TE delivers to several OEMs both Mode 2 and Mode 3 charge cables according to the IEC 62196 standards for different regions and countries. Key features of our charging systems include ground monitoring, miswiring detection, over and under voltage, overcurrent, relay diagnostics, and overheating protection. TE's AMP Plus charging cables for hybrid and electric vehicles are designed to meet the requirements of the International Charging Standard IEC 61851-1 and -22. This standard defines several types of onboard vehicle interfaces, such as Type 1 for North America and Japan, and Type 2 for Europe, with 2 charging modes, including any wall power outlet, at home, for example, and high-performance charging stations. Type 1 meets the UL 2251 and SAE J1772 standards and specifications. Our in-cable control box, or ICCB, contains proprietary circuitry to provide reliability and safety. TE's AMP Plus charging cable assemblies can be customized with specific color combinations and labeling. Our last transition is to the vehicle side of the charging path, where TE offers charger inlets for several different applications. TE's Type 2 AMP Plus charging inlet is a modular system that is interchangeable with other inlets, with minimum impact on the body of the hybrid or electric vehicle. A smart assembly method uses a small number of parts and provides finger protection on power contacts. The charging inlets are validated and certified according to IEC 62196-1 and IEC 62196-2. Our Type 2 inlet offers an optional connector locking device and a 90-degree wire exit that can be rotated. The modular inlets fit multiple package spaces and various mounting positions and can be provided with a connector locking device that can be mounted at 3 different positions. These charging inlets can be used for low-current DC charging in chargeable HEVs and EVs. TE Connectivity's AMP Plus GB charging inlet is a modular system, sharing parts between the other Type 1 and 2 charging inlets. The AMP Plus GB charging inlet conforms to the Chinese standard GB/T 20234.2. TE's Type 1 AMP Plus charging inlet is a modular system that is interchangeable with other inlets. The simple assembly method uses a small number of parts and provides finger protection on all of the power contacts. Further, these inlets offer an optional connector locking device and a 90-degree wire exit that can be rotated, all of which creates a flexible design with multiple packaging options and various mounting positions. This inlet is suited for AC charge interfaces and chargeable HEVs and EVs in North America and Japan, and meets SAE 1772 and IEC 62196-2 standards and specifications. At TE, we see the evolution of the powertrain from a purely internal combustion basis to an electrified version as a natural progression in the drive towards improved function and performance. While pure electric vehicles may not completely supplant their combustion engine counterparts, the benefits of carrying a high-voltage system on board any given vehicle are becoming more evident every year. The current generation of hybrid vehicles that seamlessly integrate a combustion engine and battery are perhaps the best harbinger of things to come, as they combine 2 methods of powering the vehicle, applying the benefits of each power source to its greatest advantage. We don't know if the future will consist of everyone driving fully electrified vehicles or some combination of the traditional combustion engine with integrated high voltage. But current market trends indicate that high voltage applications in the vehicle are increasing and likely here to stay. As long as there's demand for new and innovative products in the high voltage world, TE will continue to offer engineered custom and off-the-shelf solutions to our customers. With long-standing experience in the automotive and high voltage space, we are equipped to help our customers achieve their goals in this constantly changing environment. Thank you very much for attending TE Connectivity's TE Powertrain Revolution webinar.